Hello guys, in this video you are going to learning about Apriori algorithm and its importance. So how it is useful to mine the data. So the major purpose of Apriori algorithm is finding the frequent items or item sets. Whenever you are dealing with a transactional database which consists of huge number of transactions and each transaction is having some items. If I find the association among or the correlation among the items, I can provide such combination of items and gain profits. So now we'll see how upright algorithm will helpful to find the frequent item sets that are there in the transactional databases, which are useful to promote my business or your business. If I know the frequent item sets, I can supply more such combinations and gaining or improving the business, gaining profits and improving the business. So the major interest of Apriori algorithm is finding the frequent item sets. So how could I find the frequent item sets? So that is nothing but finding the association among the items. So it leads to finding or deriving association rule, which consists of various items. The association among various items that are there in the transactional databases. So in that process, the first step is finding the performance measures of association rule. Basically, there are two performance measures that are used to evaluate the performance of association rule. So the first one is confidence. So it tells us is a percentage of value that shows how frequently the rule head occurs among all the groups that are there in the transactional databases. All the set of items that are there in the transactional databases. So it gives some percentage of value, some confidence, support. So it is a number. What type of number it is? The actual occurrences of the items that are repeated in a frequent item set. In a frequent item set. And then minimum support threshold, minimum confidence threshold. So these two are defined by the user. In order to know the frequent item sets, these are defined by the user. The items that are there in the transactional database has to satisfy these two values, minimum support threshold value and minimum confidence threshold value. So we'll see this, how these are used to evaluate the performance of a transactional database, which is used to find frequent item sets. So what is association mining? So it determines association rule mining, which is useful to find frequent item set, is useful in finding the associations and correlations among items in large transactional or relational datasets. So the interest of discovering correlation relationships among large amounts of business transaction records can help in many business decision making process. So here what we are trying to do, we are trying to finding the association among the item that are there in item sets, the various items and the association among in the items, which is useful to improve my business. If I know that combinations at the early stages, I can supply more such combinations and gain profits. So it is useful in cross marketing, customer shopping behavior analysis, catalog design. These are some of the applications are mentioned. So these are not limited. In the market, we can apply whenever you are dealing with transactional databases. So what is association mining? How to form a rule? Association rule. So the standard rule form is the prediction predicate and the corresponding Boolean variables determines the associated prediction predicate and its corresponding Boolean variables and the corresponding support and confidence values. So what do you mean support? Is a number. What is the number? The actual number of occurrences of this combination. So what is this combination? This is possible whenever this is possible. This is possible whenever this is possible. So that is it. So how many times it is possible? Those many times it is possible. So that is the actual number that is there in the transactional database support and confidence. So we have some confidence. So if it is existed, that means this is exist. If it is existed, that means this is exist. So that is the confidence among all the transactions that are there in the database. We'll see one simple example. A person buys computer, he or she will buys an antivirus software. A person buys a computer, that person definitely will buy an antivirus software. So its corresponding support is 2% and its corresponding confidence is 60%. So if you take some set of transactions, so 60% of transactions having this combination, and actually among all the transactions 2% of such combination is existed. So that is the rule form. So we can understand like this: X buys computer, X buys antivirus software. If X buys a computer, X also buys antivirus software. So this support is 0.5%. 60% is the confidence. So we are assuming that if X buys a computer, definitely buys antivirus software. So if you take 100 transactions, 60 transactions are like this. That is a confidence. But comes to actual scenario, 0.5% transactions are having this combination. X buys computer, also buys antivirus software. So this is association rule mining. So association rule mining is a two-step process. Find all frequent item sets The item sets should appear at least as frequently as predetermined minimum support count. That is min support value. So it has, so the frequent item set has to satisfy this threshold value minimum support that is defined by the user. At least it has to meet this or satisfy this minimum support value. Then generate strong association rules from the frequent item sets, which are useful to improve the business. So how to generate the strong association rules, we'll see. The rules must satisfy minimum support and minimum confidence values. Minimum support and minimum confidence values that are defined by the user. So now a priori algorithm is useful to mine single dimensional Boolean association rules from the transactional databases. So a priori algorithm is useful to mine single dimensional, single level Boolean frequent items. Finding frequent item sets using candidate generation. So how to find frequent item sets using candidate generation? We'll see. What do you mean candidate? What is frequent item? Generating association rules from frequent item sets. So these are the three steps in a priori algorithm. So the a priori algorithm join step CK. CK is nothing but candidates. CK is generated by joining LK minus 1 with itself. So what is LK? LK is nothing but the frequent item set. The frequent item set. So candidate set is generated using frequent item set LK. CK is generated by joining LK minus 1 with itself. We'll see that practically. And the second step is prune step. So we have to prove any k minus 1 item set that is not frequent cannot be a subset of a frequent k items. It's very clear. Any k minus 1 item set that is not frequent. If it is not frequent, it cannot be subset of a frequent k item set. So we'll see the algorithm. So this is a general pseudocode of Apriori algorithm where Ck is a candidate item set of size k, Lk is frequent item set of size k. So we'll start with L1. So where k equal to 1 to n. L1 equal to frequent items that are there in the transactional databases. So we will note all the frequent items. We will note. So initially, so L1 contains all the frequent item sets, sorry, items that are there in the database. For k equal to 1, I repeat the story until Lk not equal to 5, k plus plus do begin. So repeat the story, Ck plus 1. So C2 is generated from L1. Candidate generated from Lk. What is Lk? L1. Ck plus 1 is C2. Generated. Candidate item set 2 is generated from frequent item set 1. Frequent item set 1. So in that, for each transaction T in database, do increment the count of all the candidates in Ck plus 1 that are contained in T, in the transaction T. So repeat this process. Lk plus 1 equal to candidates in Ck plus 1 with minimum support. So what is Lk plus 1? Lk plus 1 is the final frequent item set. What it contains? Candidates in Ck plus 1. What is Ck plus 1? The item sets that are satisfied minimum support value, which are frequent storage. So repeat this process until finding all the frequent item sets that are there in the transactional database. So we'll see practically one problem. So this is the example is given transactional data for an all electronics branch. So from one electronic store, we collected some of the transactional database. So which consists of two attributes, transaction ID and list of items IDs that are repeated. So transaction 100 consists of item 1, item 2, item 5. Transaction 200 consists of item 2, item 4. Transaction 300 consists of item 2 and item 3. Transaction 400 consists of item 1, item 2 and item 4. So like this way. Transaction 900 consists of I1, I2, I3. Item 1, item 2, item 3. So like this way, how many transactions we are considering? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are taking a 9 transaction database. So we are trying to finding the frequent item sets which are satisfying the minimum support value is 2. So here we are trying to finding the frequent item sets with minimum support 2. So generation of first candidate and frequent item set. So how to do this? So scan the database. So this is the database is given transaction 1 to transaction 900 and the corresponding items. So scan the database and generate a candidate item set. Candidate item set. So that is, so count how many items are there and their corresponding support count value. How many times it occurred in the transactional database. So if you see here I1 item. So now how many transactions I1 appears. So see here I1 appears in transaction 1, 1, 2, 3, 4, 5, 6. So its support count is 6. Then item 2. So how many transactions it appears? 1, 2, 3, 4, 5, 6, 7. So its support count is 7. Similarly, item 3. 1, 2, 3, 4, 5, 6. Similarly, item 4. Item 4 appears in transaction 201, transaction 402. So its support count is similarly item 5. So it appears in transaction 100 and transaction 800. So its support count is. So here what is our interest? We have to find the frequent item sets with minimum support 2. So if you see here, all the items are having support count is 2. So all are satisfied. All the items are satisfied. So now we can make it as candidate set 1, C1. Candidate set C1. So using this, we'll try to draw frequent item set 1. Frequent item set 1. So using this. So how to draw that? Compare candidate support count with minimum support count. Yes, all are satisfied. All are satisfied. So all the items are having more than the minimum support. So make it as frequent item set L1. Frequent item set L1. Because all the items that are there in the transactional database are having minimum support value that is defined by the user. The value is all the items are satisfying minimum support value. So we can make it as L1 frequent item set. So here in the first step both are same. The candidate item set and frequent item set are same. Now using this L1 we have to draw C2. What is that? Candidate set 2. So how to draw that? So L1 is the input for the next iteration. Using this L1 we have to draw. So this is L1. Using this L1, we have to find candidate set 2. So in this transactional database, we have to find the two item set combination. So we have to scan the database again and find the two item set combinations. Two item set combination and its corresponding support count from L1. So that is two item set, that is I1, I2, I1, I3, I1, I4, I1, I5 and its support count. Then I2, I3, because I2, I1 is already covered. So we start with I2, I3, I2, I4, I2, I5 and its support count in the transactional database. Then I3, I4, I3, I5 and its support count in the transactional database. Finally, I4 and I5 and their corresponding support count and make it as candidate set 2, item set 2. So I1, I2, I1, I3, I1, I4, I1, I5, I2, I3, I2, I4, I2, I5, I3, I4, I3, I5, I4. So now we have to calculate its support count. So how many times I1, I2 collectively occurred in the transactional database? So if you see I1, I2, how many times it appeared in the first transaction? It is there. Fourth transaction it is there. One time, two times, I1, I2, three times, and four times. So its count is 4, satisfying minimum support 2. Okay. Then I1, I3. I1, I3. So one time, two times, I1, I3, three times, I1, I3, four times. Similarly, I1, I4. I1, I4. So transaction 400 consists of I1, I4. One time, only one time. Next I1, I5. I1, I5. I1, I5. 1, I1, I5. 2. Then I2, I3. How many times I2, I3 appeared in the transactional database? One time, two times, three times, four times. Then I2, I4. One time, two times. Then I2, I5. One time, two times. Yes. Then I3, I4. I3, I4. So its count is 0. I3, I5. I3, I5. Its count is 1. Then I4, I5. I4, I5. 0. So we have to note down all these values. Scan D, that is database D for count of each candidate. So that is this. I1, I2 combination appeared 4 times in the transactional database. I1, I3 combination appeared 4 times. I1, I4 appears 1 time. I1, I5 2 times. I2, I3 4 times. I2, I4 2 times. I2, I5 2 times. I3, I4 0 times. I3, I5 1 time. I4, I5 0 times. So here this is the support value. Now we need to compare this with the minimum support value. What is the minimum support value? 2. So the item sets that are satisfying the minimum support are separated and named it as frequent item set 2. Frequent item set 2. Now what it is? Candidate set 2, C2. So using C2 we are trying to finding L2. How will you get L2? After eliminating after eliminating the item sets that are not satisfying the minimum support value, will get the frequent item set to L2. So compare candidate support count with the minimum support count, and the item sets that are not satisfying the minimum support value are eliminated or removed from the database. So here this combination not satisfying, this combination not satisfying, this combination not satisfying, this combination not satisfying. So these combinations are removed and named it as frequent item set L2. Frequent item set L2. Frequent item set L2. So I1, I2 4 times, I1, I3 4 times, I1, I5 combination 2 times, I2, I3 combination 4 times, I2, I4 combination 2 times, I2, I5 combination 2 times. Now using this L2 will generate C3. So that is 3 item set. 3 item using this L2. So we'll see that. So we have L2 on the transactional database. So using this L2, we'll try to find 3 item set, frequent items. So here I1, I2 and I3. I1, I2, I3, I1, I2, I5, I1, I3, I5, I1, I2, I5. So like this way, we have to find the 3 item set candidate set. So generate C3 candidate from L2. So the combinations are I1, I2, I3, I1, I2, I3, I1, I2, I5, I1, I2, I5. So these are the 2 item sets, because you need to see I1, I2, I3 is there, I1, I2, I3 is there. Yes. So that we will. Then I1, I2, I5, I1, I2, I5, it's there, it is there. Then I1, I3, I5, I1, I3, I5 is there. How many times? One time. So no need to consider. So like this way, we have to draw the item set 3. Using this, scan the database and count the support count values. That is. So I1, I2, I3, I1, I2, I3 appears, I1, I2, I3 appears 2 times, I1, I2, I3 appears 2 times. Then I1, I2, I5, I1, I2, I5 1 time, I1, I2, I5 2 times. So its minimum support count is 2. So which are satisfying minimum support count value. So this is C3, candidate set C3, candidate set 3. Now using the C3, we have to find L3. What is L3? Frequent item set. Compare candidate support count with minimum support count. So what is minimum support count? 2. So these are satisfying. So this C3 becomes L3. What is L3? Frequent item set. Frequent item set. Because this combination satisfies minimum support count value, that is 2. Now using this L3, we have to find 4 item set. So you need to check. You need to check in the database. Any transaction is having 4 items. Yes, T800 is having 4 items. So using this L3, you have to generate C4. So 4 item set transaction. What is the possible 4 item set transaction? I1, I2, I3, I5. So how many times it is repeated? Only one time. So it does not satisfy. So no need to proceed further. No need to proceed further. So we can stop with this. So This is the combinations. I1, I2, I3 appears two times. I1, I2, I5 appears two times. So these two are the frequent item sets. So like this way, we can conclude for this problem. For this transactional database, these are the frequent item sets. I1, I2, I3 combination, I1, I2 and I5 combination for this transactional data. So we can minimize it. If you take minimum support count 3, if you take minimum support count 3, so it would be vary. So like this way, we can find the frequent item sets, and if you know at the earlier stages, we can provide this combination more number of goods and improve the business. So this is about Apriori algorithm. Now we'll see some of the challenges that are existed in finding frequent item sets in Apriori algorithm. So that is multiple scans of transaction data. So what happens here, every time we have to scan every time. So if you see here, so how many times we scanned from initial steps. So this is the problem. First scan, second scan, third scan, and we obtained the frequent item set. So if you take a simple database consists of 9 transactions, we have to scan 3 times. If you, whenever you are deal with a huge transactional database, how many times we have to scan? Every time. It is a complex task, multiple scans, and generation of candidates, huge number of candidate generations, and the corresponding frequent items. So it is a tedious workload of support counting for candidates. So need more powerful mechanism to overcome these problems. So to improve the efficiency of a priori, reduce process of transactional database scans. So this is one of the suggestion. Shrink number of candidates. Another suggestion. Facilitate support counting of candidates. So these are the three suggestions or improvements suggested to a priori algorithm. Because of these problems, multiple scans, it's not easy for huge transactional database. So generation of candidates and satisfying these candidates, finding the frequent item sets is a tedious process. So we'll see in another video how to overcome this problem using frequent pattern tree, FP tree, FP growth. Thank you.